Hey, good morning. Can you hear me all right?
Absolutely. Thank you.
Perfect. Okay, so good morning, everyone, and thanks for joining us today for our webinar. As Scott mentioned, my name is Carla Jackson, and I'm the Market Development Agronomist for Deveron Veritas team. I am in Southern Ontario, so we're not far from Detroit, actually. So a lot of people joke that we're pretty Americanized in our area here. And today it might be a review for some of you that took part in our spring webinar, but it is important that we go over this and everyone understands the variability in their field. So today I'll be looking at some different soil sampling resolutions and to measure and manage that field variability. And then at the end, as Scott mentioned, I'll just do a quick demo of our free variability capture tool. That's available for everyone to try out and try on their own fields or their own growers' fields, and send us some feedback as well. I do want to mention that we will host, I think we're planning to do some weekly demos and keep an eye on your email in the coming weeks over the next month as we kind of roll out this variability capture tool. So please feel free to join in on those when you can. CEUs have been applied for this webinar, so you can send us an email with your CCA number and just saying like, hey, you've watched the variability webinar, and we can get those applied to you as well. Also, we'll just be discussing just the value of the precision ag solutions. There are 4 important steps that everyone should follow when applying precision ag, so I'll go over those. And then the bulk of the webinar will be looking at understanding your variability and choosing that right resolution that fits your farm. And then using soil analytics or soil insights to help you measure and manage that variability. And then the demo, and then some questions at the end. So as we've discussed over the course of our webinars, it's really important to look at these 4 areas when utilizing the precision ag solutions to ensure that the practices that you're using are working for your operation. The first one you want to start with is identify any issues in your field, whether it's nutrient deficiencies, through soil sampling, if you're doing research plots, figuring out the right hybrid for your farm or the right seeding rates, and just your understanding or your knowledge of your own farm of certain areas that, yeah, that area always lays wet, or that's your sand null. That information is very important to help you identify any of those issues. So once you know or you identify the issue, what do you do next? Well, you want to measure it. And you want to measure those differences with using imagery. You can adjust your crop plans by reducing or increasing your seeding rates based on those areas, and also creating management zones to help you to start tracking those differences and to improve them. The third step is where a lot of the industry is at, and that is managing those differences that you have measured by scouting those specific areas, collecting and recording that data, and by writing prescriptions based on those management zones. So you're treating those areas individually with planting scripts, fungicide, or fertilizer scripts. And the final step, which is very important and provides the most value, is validating that you're managing those areas effectively and efficiently by putting check blocks, or what we like to call variablocks, in any of your prescriptions. You can analyze that application. You can also create profitability maps that break down your efficiencies and your ROI in each management zone. They can show you the areas that you need to increase or decrease seed input costs, etc., to break even. By validating your inputs, you can also start to identify those other areas that need adjusting, and you can apply these 4 steps. Many companies offer those first 2 of identifying and measuring. Precision ag companies can offer the first 3, but there needs a lot of work in showing that validation piece. And so the point today is to show how to better validate your fields and learn from your prescriptions to make better decisions moving forward. Now on this graph, it likes to show that using traditional practices, which is this gray line, And the blue line here is the variable yield, that you're only farming the averages where the lines meet here in today's traditional practices, and you're limiting your potential. And you're leaving the opportunity on, you're over applying, you're wasting money, the environmental impact in this area here, or you are farming to the area here where you're under applying, you're leaving bushels on the table here. We can use this data to look at those outlying areas and where we can apply variable rate. Using proper application of data insights and technology to adjust the inputs in higher yielding areas and reduce the lower yielding starts to line up with your yield line. So what you're applying is actually starting to line up to what the yield productivity is. This is following your agronomist recommendations, as well as being for our nutrient stewardship, or for our nutrient compliant. Using yield data is great to start collecting to see areas needed for improvement, but it's not enough. You can see that the average yield for this field was 200 bushels an acre, but the high yielding was 385 and the low was 16 bushels. And those are the outlying parts of the graph that you can look at to start making those adjustments. Using the yield is great, but it needs to be combined with soil sampling to start making those data-driven decisions and fully understand your field variability, using as many layers as possible to create those zones. You can use the yield that you've been collecting and choose the most representative of the field, or you can use normalized yield as well, along with some bare ground imagery, or if you have some elevation data as well, you can then create soil sampling zones to test and to capture that field variability. Using as many data layers as possible to create the right zones and proven analysis is important to take your soil sampling resolution to the next level. So you can see on this field that we created the zones with some bare ground, and then we used, I believe this was a corn yield here, and they lined up fairly accurately. So you can start to see the trends in the field. On the left for this field is yield data, where we have drawn some soil polygons to separate that yield variation. And on the right is a CEC layer from soil sensor technology called soil optics, which is a very detailed look at the soil resolution across the field. No zones are created. This is the actual data from the sensors. Now, when you compare it to the 25-acre grid, which is essentially bulk sampling, you can see that you're not capturing any of that variability across the field. Same with the 10-acre and the 5-acre grid. The 2.5-acre grid is one of the most common sampling resolutions in the industry today. And compared to the yield, it doesn't quite capture that variability. 1-acre grid gets you closer, but it's very expensive. Now, alternatively, when we look at using zones or polygons, this is the 10-acre polygon. Here is the 5-acre polygon, and the 2.5-acre polygon, which many are switching to today after sampling for a few years, as it's starting to capture most of that field variability. So you can start to see it is matching up a little bit better with those yield variations. Now, when you go down to the 1-acre polygon, it looks very similar to the sensor-based, but again, it can be quite expensive. Depending on your field, each sampling resolution will differ. And for example, fairly flat fields can maybe do a 10-acre polygon, but fields with a lot of knolls, 2.5-acre polygons is needed. And then going back to the sensor-based, this example is the soil optics, and it's similar, but it's different results. Ensuring you use the best resolution for your farm is important to apply fertilizer better, while also choosing the most economical method for your operation is important. For some, depending on their end goal, the 2.5 to 5 acre polygon has the best economical value. Now, it's important to understand when you're choosing your resolution to know the difference in the methods and what you're getting. The first example here on the left is zone sampling, and is the most common entry-level sampling technique where good equipment and processes are used to create the zones and sample them individually. They are then mixed. All zone 1s are mixed together. Those are the nulls here. All zone 2s, etc., to help save money. This ends up averaging your soil results. It is still a good place to start for those not currently sampling, as it starts to capture some of that variability. The middle example is polygon sampling, which is what we typically use. When polygon sampling, using the zones that were created to that field variation, the polygons are sampled individually in an individual bag sent to the lab to measure variability as accurately as possible. So each one of these will be individual sample bags that the lab tests. The third example here on the right is soil optics or sensor-based sampling, and it has similar amount of soil classifications as zones 5 to 7 in this image of low and high ground. But when you look at the green box here, zoomed in, each one of those points is an individual sample point calculated by a sensor. In theory, each dot is equivalent to one soil sample bag. The level of information is huge and it brings a lot of value to the farm, but it's such fine detail that it's hard to manage. To help manage and measure your soil variability, we have a tool called Soil Analytics, and it is available to help provide the so what to soil sampling. Many growers don't sample due to a variety of reasons, as we saw in the poll today, but most popular is that soil results don't help answer what they need to do on the farm. The Soil Analytics tool can then help make your soil sampling data more actionable. Now, once you have soil sample, whether it's zone or polygon, you can take your soil test data and map out what the nutrient levels are in each polygon. This is a map book, and many may already see this from the soil lab or your agronomist. It is important to note that when doing any analysis on soil sampling, you should compare it to the similar year's yield. For example, if you're sampling this fall, use that fall's yield, or if you're sampling in the spring, use the previous fall's yield. So you want to use the closest yield as possible for that analysis. After your soil sampling, you can do a deeper analysis by zone compared to the optimum yield can be done. Here we can compare the fertility to the overall yield. So each image here is your P test, your K, and your magnesium. And then here is your soybean and then your corn yield, just for example. This high yielding zone, point here on the top right of this corn yield, is the lowest potassium level. It's below 100 ppm and is critical, and that needs to be looked at and start to be built up. Beside that high yielding zone, this is yellow zone here, it is a lower yielding zone, but it has one of the highest levels of K. The high yielding areas remove most fertility. With a straight rate application, you may be mining that soil and leaving bushels in the field. Alternatively, the low yield areas always been low but have been built up that fertility, so you can save money and not add any more inputs on that field. Now, one thing I want to point out is you want to look at these two zones, this red zone and this lighter green zone here on this potassium map. Both of these zones are high yielding areas, but the potassium level varies. This is a very low area, as I mentioned, it's below 100, and this green zone is one of the higher potassium levels. you can do analysis on it to start looking at that difference. We know that putting the same seeding rate and increasing your seeding rate for this high yielding area here won't necessarily work for this area here as it lodges due to that low K. To start to understand that, and you may need to dig deeper and look a little more at that fertility and other areas that's impacting it. As I pointed out at that variation of potassium and its impact on the yield, you look at the soil test and you wouldn't be able to garner that from the results. This is why many people have the questions like, what nutrients is most limiting? What are my optimum ranges? Without using the soil analytics tool or in polygon sampling, you wouldn't be able to see that variation in the field. We can do a statistical analysis on your soil result and it can help answer what that optimum nutrient level should be. When you look at the field and overlay your yield, the entire field can look at each soil sampling layer. We can then graph to look at where the yield is highest on the left and where the nutrient levels are along the bottom. You can see the opportunities where we can cut back on nutrients, but also areas that we can build. These graphs are produced using your own soil sampling data and your own yield, and you can start to see the optimum nutrient levels to obtain that higher yield. So for this example, this is the bicarb. The optimum level for your bicarb to get that higher yield for this field is around 28 ppm. So you know in this field that you need to start building up these zones or this area of the field, and you can start cutting back in those higher P areas just so you can start seeing some benefit to that yield. Now, as I mentioned on the last slide about the potassium, this is the higher yielding zones here, but that one zone where K was really low and this zone where the potassium is at the more optimum level. You can start to make those adjustments to boost that fertility and that high yielding area so you can start seeing, maybe there'll be a slight benefit to the yield there, but then you want to keep maintaining that other zone. Now that one zone that is high yielding and has high K now, it was a wet area of the field, so it's been remedied. That's why the fertility level is higher now, because they've been building it for the last couple of years and it's starting to see that yield response. So you can start to make those decisions of where you can increase and decrease your inputs to start saving some money. Now to go along with those curves, we produce these maps which show each nutrient and if it's limiting, too high or too low, as a quick and easy way to see what this field needs. This field needs MEG, the pH needs to be adjusted, so a lime application was applied. And boron showed that it was the most limiting nutrient on over half of the field. So about 7 of the 13 zones came back that your boron was most limiting. This field wasn't typically sampled for boron, but this year they decided to do it. And then an on-off script for the boron application was made at pre-plant that year just to help boost up some of those levels. These results help answer the question of what nutrients do I need to fix first. Lime was the most critical place to start, but once they correct that pH, they'll help make other nutrients more available as well. But the tools like soil analytics help measure how the yield is affecting fertility and tracking that you're making the right amendments and adjustments, such as using variable rate fertilizer scripts. Now again, going back to that graph at the start, we're looking at the outliers of the field and changing the input amounts where needed. As mentioned earlier about potassium in this field, the variable rate script put more on those higher yield, low K areas and put less in the high K areas at the back of the farm. Now looking at this K-meg oxysulfate blend here. You can see some bare ground gaps in the field, just shows you that the blend wasn't applied on the whole field. So this is just a nice example of the variable rate where you're only putting down what is needed. The data insights from your soil sampling results help target that fertilizer inputs to when it will be most utilized. So just in conclusion, wrapping up that part of the webinar, today's technology creates the opportunity to teach us something in every pass. We can become better using technology to learn faster. Using your field-specific data paired with the strong analytics provides a so what answers and the proof to help drive on-farm business decisions. Technology is here. Let's use it. You can start learning now in one pass in 1 year rather than waiting 3-4 years down the line. You're already ahead of the curve. Start collecting the data today that you'll need for the farm tomorrow. Sorry, excuse me. So that kind of wraps up the variability portion. It's just explaining the variability, sorry. How we use and capture the variability in your field. Now I just want to do a quick review of a new tool that we have called Variability Capture. Now this tool is free to use and that we offer on our website, and that you can go to the website, and if you are thinking about soil sampling or you're wondering if you're using the right level of resolution for your field, this is a great tool just to start that conversation and start looking at where you can make some changes. Maybe you need to switch from 5 to 2.5 acre polygon, or you need to switch from grid to polygon, or maybe 2.5 grid captures most of that variability in the field. So this tool is just a handy tool just to have that conversation and start looking at those areas of the field. So you can either zoom in and out on this map, or if you know the address or you have the GPS locations, the lat and long of the field, you can type it in the search box here, or just hover your mouse over the map and you can zoom in and out. Now I'm just going to go in real quick to one of my family's fields here. So you want to zoom into where it fills in most of the map. Now you're going to have to create a boundary, and you're going to want to click this polygon button here at the top left. And you're going to just click around the boundary, try and stick as close as possible to your field. Because if you get some of the trees or you get a fence line in there, it might kind of skew some of the results. But try and get as close as possible to your field boundary. I'm just doing it kind of quick here. And then to close it off, just click on the first white dot that you created, turns into a hand. Just click on that, there's your boundary. Then you click on next. Now you can choose the month that you want your imagery from. So you want to choose a time of the month where you think that you'll get the most capture the variability. For our area, we won't want any imagery in the winter just because it's snow covered. So if you want bare ground imagery for here, maybe we'll take a look at the spring months, but for this field, I'll do April. You click submit, and then it generates this report here. And it will automatically take you to this grid. So you can click grid and zone to interchange between the two. Now the color code is just to show you just some of the variation in the color. The actual image that is used for the variability capture is this NDVI image in the bottom right. That is the image that was being used for these values. So you can interchange between grid and zone. And you can see that the 2.5 acre grid, it's only capturing about 46.5% of that variability in the field. Now, if I go to the zone of the same, it's about the same percentage. It's not until I get down to about the 1 acre zone where I'm starting to capture about 77% of that variability. Now, that number is not a hard, steadfast number. That is just to show you that you do have some variability and you may have to intensively sample it, or you can do a 5 acre. This one, 5 acre, doesn't really capture a lot of the variability. So this field does have quite a bit, so I have to intensively sample it. So this is just a tool just to help have that conversation to see if you have variability, what level do I need to sample at, and just start to show you that every field does have some differences in it, and you do have to manage it differently from farm to farm or from area to area. But once you have your report, you can then, do you want to save it? You want to send it to your agronomist, to your ag retail, or if you're an agronomist and you just looked up some of your growers and you want to send it to them, you just put in your name, your email, and then we'll email you a link to the report that you can go back to the next day, a week later, a month later. It allows you to save that report, and you can go back and show them that, yep, you do have some variation in your field. You do need to start managing it a little differently. Let's look at some of your other imagery, or let's look at some of your yield and start digging deeper and to see where those changes can be made. And that's about it. So feel free to check out that website and play around with it. As I mentioned, we'll be having some more demos over the next month. So keep an eye on your email just to take part in those. Those will be quick 10, 15-minute little demos and allow you to interact with it more and ask a few more questions. So with that, I'll pass it over to Scott.
Yeah, thank you, Carla. As Carla mentioned, we will have a standing demonstration of this tool every Tuesday at 10 o'clock. We'll send out an email that'll just describe, that'll give an invitation, just like you got an invitation to this. And we'll also have it up on social media every now and then. And we'll also have it on our website, the ability to go and link. If you can, if you see the web address, variability.io.deveronuas.com, that takes you right to this. There's no password or anything like that. Additionally, as she said, it'll be hosted on the website, and there's a link right there. So this is a beta tool that we are in the development of. As she said, those are not hard and fast, specific exact numbers yet. It's an understanding of more variability, less variability, or you capturing more, or you capturing less. We would not say to go write a prescription off of this yet, because we are still in the developmental phase, but this is a good first step to start having that conversation. If you're an agronomist, with your growers, or if you're a grower, to having a conversation with your agronomist about how maybe to manage your field where there is variation. We're going to move into the question and answer session, and I see we have 2 questions already. I'll pull those up, and Carla and I will just have a conversation about what these questions are. Carla, the first question comes from Thomas, and he says, how do you take into consideration application equipment capabilities, be it row width, reaction time? From his perspective, the polygon system possibly could be challenging.
Yeah, exactly. So when we create the zones, We do take into consideration the response time of some of the spreaders. So when you're creating them, you don't want to make them too narrow, or you don't want to have them too sharp, just because you do have that consideration for that equipment. For when you're getting into, let's say, variable rate, and you want to do some check blocks in it, we create the zones or the grid to your equipment size. When it comes to just a basic fertilizer prescription where you're just kind of spreading across it, you're not doing any check blocks, we don't need your equipment size for that at all. You can just follow along the zone change and adjust that rate that way. But when you're doing check blocks, variable rate prescriptions in your fertilizer or your seeding prescriptions, that is created to your equipment size. So we do have that into consideration as well, yes.
Excellent. Thanks, Carla. The next question comes from Christina. And Carla, I can answer this one. Christina asks, can we import shape files for boundaries, or are there plans to use boundaries from the FSA similar to what Climate does? So the short answer is yes. We do plan to import these. So in the current form, this is still a developmental tool, and it's a free tool right now that just lives on the internet. It's a website that you can go to, and so there's minimal interface capabilities. So what you see right now is the current free version, and where you cannot import anything, and the only way to save it is to save the web address, the URL that we send you, and that'll forever keep the report. As we go forward and are developing this thing, we have future plans for development of the ability to both import boundaries, import FSA boundaries, and also import specific imagery. So as you saw the imagery we're drawing from right now, we're drawing from Sentinel imagery. And you're able to use our Sentinel imagery for free. But in the future, we do have future plans for you have the ability to choose the image that you use. Maybe you have a drone image, maybe you have a manned aircraft image that's a much higher resolution. And so that is future plans, but in its current form, no ability to import shapefiles right now. Please stay in touch with us, Christina, as we develop this out going forward. The next question is from Anonymous, says, do we offer soil sampling as a service? I would say yes, we do. That is one of our, that is one of the offerings we do give. So there's really two sides to our company. We're a data collection company in the precision ag world. So we collect aerial imagery, we collect soil sampling, we collect weather data, machine language, bug and pheromone data. So yes, we do soil sampling as a service. If you would like, reach out to one of us and we could have a conversation about where you are and what our capability is there. So thanks for that question. Yes, we do. We do offer soil sampling as a service.
I would just like to quickly add to that, Scott.
Absolutely.
Offer start to finish. So if you need help, if you're interested in zone or polygon sampling, or even with grid, we do that too. We can help you start to finish with setting that up, getting that going. We can do the sampling for you, or we can just do the analysis at the end of the sampling with the results. Like, we offer start to finish service. So
yeah, thanks, Carla. Thanks for clarifying. And the next question comes from Alan, and this is currently the last question. If you have a question lingering out there in your mind, go ahead and get it typed in now, because if we don't have something after I get done with Alan, we'll probably be wrapping up the webinar. Carla, Alan asks, we didn't speak much about sample quality, and he says they use Falcon to ensure sample accuracy, to have a consistent depth and spacing along with repeatability. And he's like, what are your thoughts on that?
Yeah, so when we're sampling, we do use an automated machine for sampling. So it is at the consistent depth throughout the field. And we do track the locations of each sample. So we can then collect, excuse me, we collect about a dozen samples or so in each zone or polygon. And we do save those locations. So we can go back year over year or 4 or 5 years down the road. We can go back to those same locations and sample again. And the machine that we use does have a set depth too. So we can do 6, we can do whatever depth we're needing, depending on what you're testing. But we do have that capability of repeatability and consistency with our sampling.
Yeah, thank you. We actually, good, I spurred some thoughts here. We have 2 more questions that have come in. Next question, Josh, Carla, I'm sorry, you and I can both address this and I'll get your thoughts. Richard asks, do you recommend only using bare soil image for the variability tool? So what are your thoughts on the variability tool? Which image should you use?
For the tool online?
Yes.
I assume, okay. For that, it depends on what you're trying to do. If you are just for looking at sampling per se, I would use bare ground imagery. If you're looking at for in season, if we're creating some more management zones, you could use in the summer as well, or when you have your peak vegetation there. I myself like to use bare ground imagery just to see that actual variation there.
Yeah, that was my feedback also. So yeah, it depends on what you're trying to get at, and right in line with what Carla said. So thank you. Nothing to add here. So we have 3 or 4 more questions. Yes. Question from Marion. How do we match our grid or polygon sizes with the equipment? With the equipment without compensating for averages. So how do we match our sizes to the equipment width?
So I assume to the application equipment?
Yes.
So that is, so when we take the polygons or the zone level of sampling, we overlay a grid that is created to the size of the equipment. We then pair it up to your AB line or the side that you'll be applying on. The grid itself for your application or your planter or your combine, we can create that to exactly 1 pass, 2 passes, 3 passes, whatever. We work with you on that, but that is created to that equipment, and then we line it up. So the monitor then can just follow that prescription and adjust accordingly up and down the field. So that is a whole other procedure afterwards.
Excellent, thank you. Christina asks, from the free tool, is there a file available for export to make prescriptions off this if we want to? Christina, if you could give Carla or I an email. I don't think yet we can export this file. This is, again, I still said we're still in beta phase with this, but we may be able to get something for you. If you could just give us a quick email, and we'll have that conversation. Thomas asks, he asks, how many cores do we generally pull in a 2.5 acre polygon? What are our thoughts about that?
We typically are around, I think we're around a dozen per zone, like polygon right now. As typically, I think what they're doing, yeah.
Thank you. Somebody has asked if we could resend the link, and I have both sent that to that person individually, and if everybody else, if you look in the chat panel on the right-hand side, I copied the link in the chat panel to the right, and you'll see that there. It's variability.io.deveronuas.com. You can click that link, or you can copy it and then just save it. And again, that it's also on our website, and
or YouTube. There's a video on YouTube too, providing a demo with the link to it there too.
Absolutely. So we're doing all we can to get this out there. Ozan asks, can we apply this solution to orchards? What's our thoughts on orchards?
Scott, would you be able to provide, you're a little more familiar with orchard.
Yeah, I was going to try to maybe Carly could to get that. I would say precision does work for orchards. We are not, we have not specifically worked heavily with orchards. We have partners who do though. And Ozan, I would say, let's have a conversation about what your challenge is with orchards. I mean, we know imagery works. We know soil sampling works. We would just have to understand, we work with high value crops such as blueberries and vineyards. I mean, we do work in all of those other types of agriculture production. So let's have a conversation, Ozan, about like how dense your orchard is and what you're trying to get at. And we'll see how we can help you out. But absolutely, precision tools work for orchards. We just need to find out what your question is. It looks like we're getting down to the bottom. We had a whole bunch more questions jump on there, which is great. So please, if you still have them, please send them. And everybody's generally staying on, so it looks like the questions you guys are sending are helping everybody else out. Marion asks, many times the polygons do not line up in the direction of the application pass. What are your thoughts on that? And just have a conversation, because yes.
So I know you're not applying directly. I know for our area, we're not directly applying in that zone. So when we create the grid for application, we can create it in any direction. So usually the spreader can then adjust to whatever zone that you're going through. So I think in our area, we haven't run into that issue about with the direction of the application to the polygons. So I can't answer that specifically just because I haven't much run into that issue too much, but feel free to send me an email.
Yeah, and I will just make a general comment. The field's variability is what the field's variability is, and the best you can do is manage it the best you can. It might not always be perfect, and that is one thing we do. I mean, that's one of our tenets is keep learning each year. So as we help our clients, if we have a script written out for them, a variable rate application for whatever, we always do an ROI analysis at the end of the year and determine, did we make the mark or not? And as Carla showed you those response curves there halfway through the presentation, we do those on every script that we send out that has an ROI analysis. So if we're off a bit, we'll make the corrections as best as the equipment can help us. So yeah, great question. I don't see any more questions. And well, actually, I do have one more question from Anonymous. So Anonymous asks, what's the process for proving the ROI? What do you need to prove an ROI? Carla, what are your thoughts on that? And I can talk also once you get done.
Yeah, so we need, typically the layers we need for that analysis is the application. If a script was created, we use that script, we use your application or as applied data, and then also the yield. So it depends on what the application was or what the script was, but those are typically the 3 layers that we need to do the analysis at the end of the season. When it comes to looking at fertilizer, we're doing check blocks. If we're doing check blocks in your fertilizer application, we can then look at the specific rate or even product. If we're doing a blanket application, a fertilizer application, we can just typically look at your yield and your nutrient value. So we're using your soil test data and we're looking at your yield, and we can do an analysis that way as well. But typically for all applications, it's your script, your as applied, and then yield will get you a far, get you a long ways.
Yeah, and just to add to a bit about that, whenever we put in our randomized check blocks throughout the script, and the client gives us the yield, the calibrated, the good yield data at the end of the year, we're running the numbers, all the blocks against all the other blocks to compare how the response rates did. So it's not just one, it's not one check strip down the center that may be skewed left or right because it was in good land or bad land. We put what we call check blocks throughout every zone, and we're pushing the rates higher and lower through every zone, and then comparing all of those numbers throughout the field. So that's how we'd say prove an ROI. And what do we need to prove it? We need, we can even do some analysis if you don't have our check blocks in there, but it's not going to be as good. There's not going to be as many randomized numbers to validate it. We can do work on just any script as long as we have a good as applied data and a good yield data. And then Bryce makes a comment on equipment not matching up with the zones, and right on, Bryce, saying you still need a sample in those zones because that's how the field is. And even if you can't apply whatever your product is exactly back to those zones, you at least need to sample in those zones to get an accurate representation of your full field's capacity. So thanks, Bryce. And I think that is the last question. They kind of slowed down there in the end. Hey, everybody, I appreciate everybody joining us today. This is really great. And the question and answer session is really where we do a lot of our learning. We really get to understand what the challenges are out there with our clients and our partners. And we really appreciate the good question and answer session. So if you ever join us, please come with good, hard questions. We appreciate it. We'll continue to do the webinar series. We'll put one out about every 2 to 3 weeks, and we'll advertise via social media, referrals, and email. And so and feel free to share them with anybody that you may know. We also record all of our webinars, and they're hosted on our YouTube channel. So if you just search YouTube by Deveron UAS and go there, there'll be different categories of videos, and you'll see a playlist for webinars, and you'll see all of our past recorded webinars. I think there's 7 or 8 of them uploaded right now. Go, and if you want to watch any of the back webinars, you can, and just again send us your email that you've watched whatever that webinar is you watched, and we'll get you credit for that too. So again, thanks for joining, everybody. We appreciate it. It's been a great day, and look forward to seeing everybody on the next webinar. Thank you.